Today we're solving problem 23 from the Spring Amc 10B from 2021. A square with side length 8 is colored white except for 4 black isosceles right triangular regions with legs of length 2 in each corner of the square and a black diamond with side length 2 root 2 in the center of the square as shown in the diagram. A circular coin with diameter 1 is dropped onto the square and lands on a random location where the square is completely contained within the square. The probability that the coin will cover part of the black region can be written as 196 times a plus b root 2 plus pi, where a and b are positive integers. What is a plus b? Well, I have drawn this out, and these regions are supposed to be shaded, but I didn't shade them in because it will make it a lot harder to read later. What are we given? So these are two. These are isosceles triangles, and specifically right isosceles triangles because this is a square. We were given the total length is 8, so therefore this is 4, this is 4, this is 4, and this is 4. Now, it says about the coin, not the area. It says that the coin is with diameter 1. Be careful on this, because the diameter is 1, that means the radius, I'm really bad at doing this, r is equal to 1/2, because the diameter is 1. Now, if the radius is 1/2, then the total area doesn't count because it can't land on these borders. The center of the circle can't land on these borders because then it'd be partially out of the square. So we have to map out a region where the center has to land. So it's like about this, where all of these lines are supposed to be equidistant from the edges because its center point has to be 1/2 away from it in order for it to actually land in the circle. We were also given that this is a square on the inside, and, well, 2 root 2 is its side length, 2 root 2. So basically we can find the total amount of area that the coin can land, and make it a factor of 196, where a and b are positive integers. Okay, so, well, what do we know? If these two segments are 1/2, then, and this total area length is 8, 2 1/2s make a 1. 8 minus 1 is 7. Same goes here. This side length is 7. 7 times 7 is 49. So we know that the probability is going to be something over 49, and it wants us to express it in 1 over 196, and 49 is a factor of 196. So, what can we do? We can first find the easy areas. Let's just find this area of the black square thing. So, this is 2 root 2, essentially squared. This yields an area of 8. 8 units, 8 giraffes, 8 whatever, but it's units in this case. Now, we can also find the probability where it just touches the square, and that's like 1/2 units away from it. So about like this. And there's 4 of these, but I can't draw the other 2 or else it'll cover it up. This height is going to be 1/2, and we know that this length is 2 root 2. 2 root 2 times 1/2, this is root 2. That's the area of one of these segments. We got 4 of them. So root 2 times 4 is 4 root 2. But again, we're not counting enough. There's these annoying little circle thingies. So all these 4 little circle thingies form to have one small circle like this, where 1/4 of these portions are equally distributed among these like 3 edges, I guess. And this is 1/2. The radius is also 1/2, which is like the same radius as the coin. So 1/2, we can find the area. This is pi over 4. So basically, we have this, which is the area of the black square. We have 4 root 2, which is the area it can land on, and pi over 4, which is the edges it can land on. Now we actually have to consider the triangles, and this has to be a bit more precise for this. So we can first find out. We don't have to find out anything. It's a bit confusing. It can still land on here, even if it's on the edge of the black. This bordered region is how far it can land. It can also land here, just touching it. And we know that this distance is 1/2. So we want to find the height. And, well, better the length. But there's a formula for finding types of triangles like this. It's not too hard. We can find the height, or rather this remaining height, I guess, because, well, simply put, that height is going to be 2 minus root 2 over 2, plus that 1/2, because there's this 1/2 being added to it. Okay, now this is going to be root 2 plus 1 over 2. That is the height. And if we ever want the area of this, we have to square it. So root 2 plus 1 over 2 squared. This gives us fully simplified 3 plus 2 root 2 over 4. Now, we just found the area for one of these triangles. What we want to do is we want to multiply by 4. 3 plus 2 root 2 over 4. And why do we multiply by 4? There's 4 triangles. So this is 3 plus 2 root 2. Now, we seem to have all our lengths. So when we add them all up, we get 8 plus 4 root 2 plus pi over 4 plus 3 plus 2 root 2. And this is all going to be over 48. 49, because 49 is the total region that the coin has to land on. This eventually yields, well, we want a common denominator, so when we get to the common denominator, we get that this is 44 plus 24 plus 24 root 2 plus pi. This is going to be over 196. Because, first of all, you add this to get 11 and then 6 root 2. You take out the factor of 4 in all of them to get a pi. And then 49 times 4 is, lucky, 196. We want the sum of A plus B. 44 plus 24 gives 68, which is our answer.